Hi everybody, my name is Kavita Deodhar. Today I'm going to talk about AWS Redshift, which is the topic of my final project. The agenda of my presentation is as below. Introduction to AWS Redshift service. Then we talk about features and benefits. We talk about the disadvantages of using this service, a brief overview of the architecture. Then I'm going to describe the problem statement that I used for my demonstration and the final conclusion. Let us now see what is Amazon Redshift. Amazon Redshift is a fast, fully managed petabyte scale data warehouse service which can be integrated with our existing ETL tools and reporting tools. It can be compared with a data warehouse appliance like Netezza and Teradata and high performance hardware like Exadata. This service is based on PostgreSQL, and it can also be integrated with other Amazon cloud offerings like Amazon EMR, Amazon Data Pipeline, and Amazon RDS. Let us view a couple of features and benefits of Amazon Redshift. Amazon Redshift is a service that is optimized for warehousing solutions. It is scalable in the sense that as the needs of our data warehouse change, we can keep adding nodes with ease. Also, this service is less expensive. In case of an on-premise data center, there are hardware costs associated which can be easily avoided using Amazon Redshift. We only pay for the resources that we provision. Also, security of the data warehouse can be ensured either by using database encryption or by using HSM. Also, it is possible to isolate the entire DW cluster by using virtual private cloud. This service is very easy to use, as from the time that you sign up for this service and till the time that you bring up your first cluster, it is just a matter of minutes, as opposed to using an on-premise database wherein there is a lot of provisioning and a lot of resourcing required. In this case of Amazon Redshift, Amazon manages, monitors and applies patches and backups for the warehouse. Also, data replication happens on a set time every day to S3 as well as to other nodes in the cluster, due to which reliability can be ensured. Automated backups in the form of incremental snapshots are also stored by Amazon. It is fairly easy to restore data from these snapshots. Since Amazon Redshift is based on PostgreSQL, ODBC and JDBC connections are easily available to use so that we can integrate with the existing ETL and reporting tools as well as any other SQL-based development tools. Also, it is designed to be used with Amazon S3, Amazon DynamoDB, Amazon EMR, and Amazon RDS. The disadvantages of using this service are, if at all an organization has already heavily invested in DW specific appliances and hardware, the cost of moving to Amazon Redshift can be fairly high, and hence Amazon Redshift may not be suitable for that kind of an organization. Also, depending upon the size of the data warehouse, this service may sometimes be more expensive than an on-premise database, as the cost of the smallest node that is offered by Amazon Redshift at this point is 85 cents an hour. Also, since this is a fairly new technology, there is not a lot of expertise or not a lot of best practices that are available for this technology. Now let us take a brief look at the architecture of an AWS data warehouse cluster. As you can see on the screen, we have a set of client applications which are nothing but SQL development tools, ETL tools, reporting tools that communicate with the data warehouse cluster. Since Amazon Redshift is based on PostgreSQL, they use JDBC and ODBC connections to communicate with the nodes. An Amazon warehouse cluster typically has two types of clusters. One is either a single node or a multi-node cluster. In case of a multi-node cluster, there are two types of nodes available, which is leader node and compute nodes. There can be more than one compute nodes, and there will only be one single leader node. Leader node manages the communication between the client applications and the compute nodes. It also compiles the query that is sent by the client applications and assigns the queries for compute node to the compute nodes for actual calculations. Compute nodes process these queries and send the results back to the leader node for final aggregation. Here is the problem that I'm trying to solve. Our organization is looking at migrating our data warehouse environment to a better performing hardware and higher capacity, which will meet our future data needs. The tool we currently use for loading data is Informatica, and the reporting tool is Tableau. We already have an extensive set of reports and dashboards that the executives of the organization heavily depend on. Hence, we want to move our technology that can cater our needs without needing us to discard our existing ETL code and reports, and that causes minimal disruption to the users. This exercise is to verify if the existing tools in the organization can be easily integrated with Amazon Redshift. In this demonstration, we will go over the process of creating a new cluster on Amazon Redshift, create a set of tables to produce a mock report that shows sales in millions by day by region. We will also use Informatica's cloud service to load the data and Tableau to generate the reports. Since this is a presentation, I'm just going to go over the parts wherein we use the Amazon's Redshift service and the JDBC and the ODBC connection URLs. A detail of how to achieve this or how to physically code for this problem is present in my demonstration video. Here we look at the cluster that we created. A cluster is the core component of an Amazon Redshift service. It is composed of either one or more nodes depending upon whether a cluster is a single node or a multi-node cluster. In case of a multi-node cluster, there is a leader node and more than one compute node available to us to use. In this case, we are going to use a cluster with 2 compute nodes and a leader node. Here is a snapshot of the cluster properties. It shows the type of the cluster of my DW cluster, which is multi-node, node type, which is DW HS1 X large, and the number of nodes, that is 2. It also shows that the cluster is available. The cluster database properties shown here are important as they show us the JDBC and the ODBC URLs for connecting to the client applications that we will use, as well as the name of the database, which is SalesDB, and the master user of the database, which is master user. In order to create tables in SalesDB, we use a tool called as SQL Workbench. You will need to download SQL Workbench for PostgreSQL and also a PostgreSQL JDBC driver. We have to use this to configure the connection. Provide the JDBC URL from the cluster properties. Also use the same connection information, that is the username and the password, as was used when creating the cluster. After we are able to connect to the SalesDB, we will go ahead and create 3 tables. For the purpose of our exercise, we are going to create 3 tables: region dim, date dim, and sales fact. Now that the tables have been created, we start loading data using Informatica Cloud Services. The step-by-step demonstration or the step-by-step tutorial is present in my demonstration video. You first need to sign up for Informatica Cloud Services trial and then download Informatica's secure agent before we start creating any tasks. Here I am just showing the screenshots of the Redshift connector configuration. You will actually have to create a task to load data and use this Redshift connector as the target connection. The source in our case is a flat file source. Once the task is complete, then run this task on demand in order to load this data. Here we see that the data has been successfully loaded to the table created on the SalesDB database. Please see that the copy statement has been generated. Before loading data to this table, I had created a bucket called as Kavita Redshift. The reason for creating the bucket is the process of loading data from external sources to Redshift. You first have to load the source file onto a bucket in S3 and then manually issue a copy command to transfer the data from this S3 bucket into the target table that you created on the Redshift cluster. Informatica Redshift connector replicates this process. it first generates a flat file from the source, then it uploads it to the bucket that we specified when creating the load task, and then it internally issues a copy command to transfer data from the flat file to the table with the S3 bucket in between. Thus, it simplifies the process for us. Finally, we set up a Redshift connection on Tableau. Tableau is a software that we will use to generate the reports. It uses the ODBC URL. It uses an ODBC connection to connect to the Redshift database. The username and the password is what we used to connect to the database. And in the screen, as you can see in the screenshot, there are 3 tables that will be used to create this report. This is how the final report looks like. Here are the sales by region, by year, and the sale amounts are in millions. The final conclusion of this exercise is that the existing tools can be easily integrated with AWS Redshift, and our existing code can also be reused. However, in spite of paying for the resources we provision, this service may tend to be a bit expensive, considering the cost for even the smallest node is 85 cents an hour. The cost aside, there are benefits like ease of use and scalability that this service has to offer, due to which it is an option to consider if we decide to change our existing data warehouse solution. Here are a couple of links and the resources that I used for my final project. Thank you.